Woohoo! We are live, and this is part 4 of a series on problem solving using systems of equations. So in other words, situations where you've got not just one, but 2, or maybe even 3 equations. But spoilers, I'm just going to talk about the 2 equation types. So we have come to our last problem. So I've got my little word problem helper outer here. And we're going to go ahead and read through, but spoilers, I already told you this was a mixture problem. Let's see if we can recognize it. The owner of a tea shop would like to blend. Ooh, there it is right there. The word blend. Blend means mix. So that word, generally speaking, sorry, Sharktopus, means mixture. Okay, but we can keep going. The owner of a tea shop would like to blend black tea that sells for $15 per pound with peach tea that sells for $10 per pound. Technically, it's a tisane, but we're going to overlook this, to get 5 pounds of a blend that would sell for $12. How much of each should they use? Pardon me. And as with all the other problems that you will do that are mixture types, you are welcome to start with this. It's not required. But you can say, okay, I should go through this. Read through the problem. Is it a type you recognize? Yes, it's a mixture problem. Woohoo! So we take this card away, and then very quickly we make sure that the problem makes sense. So I draw a little line segment here. I've got the black tea here. And I've got the peach tea over here. And the black tea is $15 per pound. Remember that pound can be shortened to LB. And peach tea is $10 per pound. And we want to get 5 pounds of a blend. And again, there's that word blend, which means mixture. That would sell for $12. And I think about it and I think, okay, 12 is almost in the middle, but ever so slightly closer to peach, because halfway between 15 and, oh, I reversed it, didn't I? And put 15 over here. Sorry about that. So right here in the middle is $12.50. And we want a blend that's going to sell for $12. So it's ever so more close to the peach. So we're going to use a little bit more peach, a little bit less black tea. And because I am just awesome, the way you guys are all awesome, I have prepared for you, the mixture card. I did this myself. I know, this is amazing. Even more amazing that the state pays me to do this. It's probably a good idea because I can't imagine what would happen if I were just wandering the streets trying to teach people word problems. That would be horrible, right? So it makes sense. So here's our mixture problem setup. And we've got the chart, which again is completely optional. And in the chart, I've got a top row, which has just titles, and a left column that has just titles. Again, you can set this up however makes the most sense for you, because this is just to help you organize the information. You'll notice, like we did in the last problem, I've got the total amount. Here is going to be the percent from the last problem or the price. It really depends on what kind of a problem you're doing. And then the last one, and again, I can't, there's so many different types, I can't write exactly what it's going to be, but it'll be the amount of, like in the previous problem, amount of ammonia, or the total cost. So you've got those titles, our happy face in the middle, because like, what would you rather be doing? Word problems or going to the beach? I rest my case. Here on the left side, I'm going to write down the first thing I'm mixing, the second thing I'm mixing, and then I've got a row for the mixture or the blend. And then a reminder that generally speaking, and again, this can change, but generally speaking, this first column is going to give you your first equation, and the last column will give you the second equation. So this is our general setup. So using that, let me go ahead and move it up here. I know I can't see the problem, but I remember what it was. I'm going to go ahead and set up my rectangle. Does not have to be perfect, but of course you can absolutely use a ruler, make it all pretty. You can use colors. You can do whatever you like. So I've got 4 rows. The title row, the first thing I'm mixing, the second thing I'm mixing. Notice that you could put in a third thing if you're mixing 3 things. We're not going to be doing that in this video, but you could. And then this is the mix or the blend. Okay, so let me take this away so I can see the problem. And I've got the total amount. Goes here, and then another, and then another. So let's take a look. So we're going to blend black tea. Here's the black tea. And that's $15 per pound. So right here, instead of percentage, I'm going to put price. This is $15 per pound. And then I've got peach tea, which sells for $10 per pound. So let's stop here for a second. Take a look at what I've got. I wrote out the black tea and its price right there, black tea and price, and then the peach tea and its price. And then we would like to get 5 pounds of a blend that would sell for $12 per pound. So that 12 goes right there. So this is the price per pound of each of these. And then we look, do we know any total amounts? And the answer is yes, I see a total amount. I see it. Let's see, what color have I not used? Let me use orange. I haven't used that in a while. So I'm going to get 5 pounds of a blend. So that means down here, I want to put 5 pounds. This is important. So when you're solving word problems, generally speaking, you want all the units to work out. So since this is price per pound, this should be pounds. See how they match? Yay, it's good. If this were 50 ounces and this were pounds, then we'd have to convert. Okay, so it seems that we don't know how much of each of these we're going to use. Let me check the final question. The final question. See, read the final question to set up the variables. How much of each of the types of tea should they use? Okay, I need variables here. And I'm going to go ahead because it's still pretty early on. If you've never seen a mixture problem before, I'm going to use X and Y. But I really, really, really encourage you to use other variables, A and B, or B for black tea and P for peach tea. Live it up. Take advantage of all the choice you have. Okay, so I'm going to remind you that as we move across, generally speaking, when we're setting up a mixture problem, we're aiming for multiplication. Why does that make sense? Well, let's take a look. I'm going to go down to the bottom like I did before, the last row. If I have 5 pounds and they cost $12 per pound, what happens when I multiply? What am I going to get? I'll get 5 times 12, which is 60, which is the total cost, right? If they're $12 each pound, if I've got 5 of them, I'm going to be spending $60. So multiplying from that perspective makes sense. So let's go ahead and multiply across. I've got X pounds at $15 per pound. So that's X times 15, or usually we write the coefficient first, right? So 15X. For this one, I've got Y times 10 is 10Y. Okay, so now let's take a look at this. Make sure all the information in the problem is included in the chart. And then once we've done that, then we sneak our hand right up here and we say, no more telling me beep, beep, beeps, my computer. Okay, so let's take a look here and see the mixture problem master chart master. Woohoo. So for mixture problems, we set this all up, and then we remember that generally when we set them up this way, We're aiming for multiplication across, which we did confirm totally makes sense in this case. And then also we're looking to add going down. So can we add? If we add the x plus the y, does that give us the 5 pounds? And the answer is yeah. 5 pounds is the amount of the total mixture. So we're going to add x plus y. So this here is going to be our first equation right there, because that's just looking at the amount of tea we're using. That's our yellow. Sorry, took you to Smearytown. And then also, now can I add prices? No, you cannot add prices, just like you cannot add percentages. So next up, I've got the last column. So what does it mean if I'm looking at this last column? I've got 15x, that's the total cost for the black tea. And then 10y, that's the total cost for the peach tea. And then I know the cost for the blend should be 5 pounds at $12, so $60 altogether. That's what I'm aiming for. So I want to make sure that the 15x plus the 10y equals 60. Now, why do we need both equations? Well, we need both equations. I mean, the easy answer is we need both equations because, as I've mentioned, if you have two variables, you need two equations to know what's going on. It's kind of cool the way that works out. But why? Well, the first equation tells you that you need a total of 5 pounds, but it doesn't tell you how to split that up. So you could have like 2.5 and 2.5, or you could have 3 and 2, or you could have 4 and 1, or you could have 1 and 4. I mean, lots of different ways to do it. This first is just kind of gives you a general idea of what's going on. But the nitty gritty is over here, usually in this last column, because this column is telling us that the black tea is priced a lot more expensively. So we're going to be multiplying x times 15. And y is only multiplied by 10. Y is a lot less expensive. And so that will help us figure out if we want the total cost to be 60, x is going to be multiplied times 15. Y is going to be multiplied by 10. So we're going to need probably different amounts of each of them. Right? And that's what we found. Let me slide this down. That's what we found right here. Given that we're aiming for a blend that's $12 per pound, it's a little closer to the peach price. So there's going to be more of the peach tea in it. Okay. So this one, it turns out, although some people find it harder because I'm not sure why. I will say I'm not sure why people find it a little harder, but sometimes people do. However, the silver lining is that there are no decimals here. Now, I'm lying a little bit. Could the price be a decimal? Yes, it could. So it could be that at this step, not in this one, but in another one, you may need to clear decimals. So be aware, be ready to do that. But in this one, it's pretty sweet. I'm all set up to cancel, and either I want to cancel my x's or I want to cancel my y's. I'm going to cancel my y's. I have 10y here, so I'm going to multiply by, you're right, negative 10. Woohoo, up top. Not going to touch the bottom one. So that equation stays the same. Up top, I've got negative 10x minus 10y equals negative 50. And when I add them, I get 5x. The y's cancel out, equals 10. Oh my goodness. How lucky did I get? 5x over 5 equals 10 over 5. So x equals 2. Oh my goodness. And then to use the space, I'm going to bring our eyeballs back over here. I know it's a little bit weird. Feel free to go on to another page. I just learned to do this decades, really centuries ago, back, in the 1430s when paper was very expensive back then. You had to find someone and it was a whole thing. You basically had to grow your own paper, So I've got x equals 2. And I know x plus y is 5. 2 plus y is 5. y equals 3. And unfortunately, I've totally run out of space, so I'm going to have to use another page. I tried to avoid that for you, but unfortunately, there's nothing to be done. So let's see what we can do about answering this. Now, it could be that for some folks, this is all you need to do. For me, for my class, if you were to take the x equals 2 and the y equals 3 and box them, we're good. In another class, though, they might want you to write more. So let's see what more we could write. Well, what we could write would be, and remember, when I'm going to a new page, I never change anything. I just write down what I had before. I don't try to do anything in between pages. Okay, so let's see. X is the amount of black tea. It's the number of pounds. And Y is the peach tea number of pounds. Okay, so we've got 2 pounds, and you can write out pounds if you want, of black tea. And 3 pounds of peach tea. And then it's nice to box things when you're working on a word problem, because a lot of times your work can get kind of messy. I mean, mine was pretty okay, but it is a little bit hard to follow. So, you know, boxing your answer makes life easier for you and anyone who's looking at it. And let's take a look. Does it make sense? We predicted more peach tea because it's slightly closer, less black tea. Did we get more peach tea and less black tea? We did. Oh my gosh. Y'all, we are done with this chapter's word problems. Yay! It's dance party time. I hope you guys have a great day. I hope you go out and see some sunshine, get some exercise, eat some vegetables, hydrate. And I'll see you in the next video. Woohoo, math on.